we want to look at, essentially, r of x equals 3x plus 5 over x minus 6. First thing I always go after, by the way, is the domain. And the reason for that is that gives me what the VA potentially is. And I will, when we start graphing, I'll explain to you when that's not going to be the case. So if I take a look at the domain is going to be, well, we have x minus 6 can't be 0, x can't be 6, so it's all real numbers except for 6. For us in this class, with our focus, we can then say the VA is x equals 6. Because remember, VAs are caused by divisions by 0. The next thing I want to do is I want to go after the end behavior. So I now have the vertical asymptote I'm going to need to graph. I need the end behavior asymptote for these graphs because that shapes the graph out. So I have to have pieces of information so I can do the stupid graph. So the end behavior model is the quotient of the highest powers. That's 3x over x, which is 3. This is a constant degree 0. It is a number. When I come out with a number, that is the asymptote. I have an HA because it's a constant. And what is the asymptote? It's y equal 3. So when I go to do my graph later on, the first thing I would put in is my VA, and then I put in my HA, and then I work my graph around these dotted lines. Oh, yes, should be 3. I know I was thinking 3. I don't know why I didn't write it, but thank you. Y equal 3. And then I work my graph around those dotted lines, which makes my life really easy because I don't have to graph a lot of points. These graphs on the calculator are really ugly. Here we go. Domain. Well, denominator can't be 0. X cubed minus 1 can't be 0. X cubed can't be 1, or x can't be 1, because I take the cube root of both sides, because essentially what's going to happen in between here, take the cube root, take the cube root of x cubed is x, cube root of 1 is 1, so x can't be 1, so it's all real numbers. X can't be 1. That means for us, the VA would be x equal 1. End behavior model is the quotient of the two, which is 4x over x cubed, which is 4 over x squared. So that's the model. And now I look at as x goes to infinity. What?
4x squared over x cubed.
Okay, which is then going to be, oh, that makes life easier. 4 over x. Good news is the result's the same. So this essentially becomes 4 over infinity, and now we know 4 over infinity is 0. This is a number, which means I have an HA, and the HA is y equal that number, which is 0.